We're now moving on to question number 80. Question number 80 is again a conceptual question, and in this question you actually need to know three concepts. They are the intermediate value theorem, intermediate value theorem. To use the intermediate value theorem, it is enough to know that f is continuous. And so let's use our information. We have f of negative 2 is equal to negative 5. F of negative 2 is equal to negative 5. And we are told that f of 1 is equal to 4. So we have the point negative 2, negative 5. And f of 1 is equal to 4. So we have the point 1, comma 4. So when x is 1, y is 4. Draw the y-axis, draw the x-axis, plot negative 2 and negative 5. Plot 1 and 4. And now let's do the questions that have to do with the intermediate value theorem. The two questions are A and C. So I'm going to write an IVT by that. One possible graph, and I'm not saying that this is the graph, but let's give the simplest graph, which is a segment joining the 2 points. So the intermediate value theorem states that if a function is continuous, then the function must take on all the values from 4 to negative 5. So as you can see, in the interval from negative 2 to 1, indeed there is a c for which f of c is equal to 0. F of c is equal to 0 because there's no way a graph can start below the x-axis and go above the x-axis without passing through the x-axis. So there is such a point in the interval from negative 2 to 1, and f of c is equal to 3. Yes, there is a point whose coordinate is 3 as well. So the intermediate value theorem assures us if f is continuous, it must take on all the values from negative 5 to 4. Since both 0 and 3 are between negative 5 and 4, such a constant will exist. So let's just write that down. So f must take on all values between negative 5 and positive 4, both 0 and 3 are between negative 5 and 4. Okay, so both A and C must be true. Next we go to E. F of c is greater than or equal to f of x on the closed interval from negative 2 to 1. There is a theorem that states that if a function is continuous, then on a closed interval, it achieves both an absolute max and an absolute mean. So, min. So, from the information given, we see that f of c is the absolute maximum. And there is a theorem that states that if a function is continuous on a closed interval, then the function will have both an absolute max and an absolute min in that closed interval. We're going to refer to our graph. I drew it in such a way that the absolute max actually occurs at the right-hand endpoint. It doesn't have to occur there. This is just a possible graph. So this is also true. We're now left between B and D. If you look at one possible graph, you can see there is no point where the derivative is actually equal to 0. So really, the only one that can be false is B. How can I show that D must be true? You must use the MVT. What is the MVT? The mean value theorem. Let's go over it one more time. So mean value theorem. For us to use the mean value theorem, the function must be continuous and differentiable. It is. And what does it say? If the function is continuous and differentiable on the interval from A to B, then there exists a point C that's between A and B. So A is less than C, less than B, such that f prime of C is equal to f of B minus f of A over B minus A. In our case, f prime of C would be equal to f of 1 minus f of negative 2 over 1 minus negative 2. It would be equal to 4 minus negative 5, that's supposed to be a 5, over 3, 9 over 3. So f prime of C would have to be 9 over 3, so this must be also true. So conceptual question, 3 concepts: the intermediate value theorem, the mean value theorem, and the last one is the theorem about absolute max and min on a closed interval. That's it for number 80. We now move on to number 81. Number 81 is a graphing calculator question. It says, how many relative extrema does f have on the interval from 2 to 4? So let's review what is a relative extrema. A relative extrema is a relative max or min. Where does it occur? Extrema occurs at a critical point where f prime changes sign. What is the critical point? At that critical point, f prime equals 0 or f prime is undefined. So again, a relative extrema is a relative max or min, and the extrema occurs at a critical point where f prime changes sign. We take our graphing calculator now, we turn it on. We go to y equals, we clear what we have. Remember, we already went to mode, we already know that we are in radians. So back to y equals, and we enter sine of x squared plus 1. Before we go on, we change the window. This time our window needs to be between 2 and 4. And we leave the y's the same, and then we draw the graph. And then we count. 1, 2, 3, 4. The graph has 4 x-intercepts. And at those 4 x-intercepts, the graph of f prime changes either from below the x-axis to above or from above to below. In other words, f prime changes from negative to positive or from positive to negative. And that's it. So the number of relative extrema will be 4. End of